In this video, we'll be looking at converting the mass of compounds to moles. On our mole map, the units we'll be using for these calculations are grams to represent mass and mole. So 1 mole will equal the mass of the substance in grams, and we will use the periodic table to determine the molar mass of any element or compound that's given to us in a problem. In problem number 1, we're given 162.3 grams of magnesium fluoride. So let's write our given value. We'll be performing these calculations using dimensional analysis. Our next step will be to fill in the units. Since we're trying to get rid of grams of magnesium fluoride, we'll put that in the denominator. And we're converting to moles, so moles will go up in the numerator section. To convert grams to moles, we're going to use 1 mole over the molar mass of magnesium fluoride. Let's look at the periodic table to determine the mass of this compound. Remember, when finding the molar mass of a compound, we're going to split up the elements in the compound and write down the quantities of atoms in the compound. So we have 1 magnesium atom and 2 fluorine atoms in 1 formula unit of magnesium fluoride. Now let's look up the mass of magnesium. We're going to round that to the hundredths place, so it's going to be 24.31 grams per mole. Then let's look up fluorine. The mass of fluorine will be rounded to 19.00 if we round to the hundredths place. So we're going to multiply that by 2. One times 24.31 is 24.31. And 2 times 19 is 38. To find the total mass of magnesium fluoride, we need to add up the masses of the individual elements. (62.31 grams per mole) is the molar mass of magnesium fluoride. Let's take this number and put it in our dimensional analysis table. Now we'll use our calculators to determine the number of moles in 162.3 grams of magnesium fluoride. In dimensional analysis, we're going to multiply the top, 162.3 times 1. It's the same thing. So we just simply divide 162.3 by 62.31. Remember to record your answer in significant digits. Since we're given 4 digits in our value to start with, we're going to round our calculator answer also to 4 digits. So the answer comes out to 2.605 moles of magnesium fluoride. For our next example, we'll be converting 8.5 grams of phosphorus trihydride to moles. Let's start by writing our given value. Now we'll set up our dimensional analysis table. We're going to cancel grams of pH3, so we'll put that in our denominator. And we're converting this to moles of pH3, so that label will go in our numerator. Now let's take a look at the periodic table to determine the molar mass of pH3. We have 1 phosphorus and 3 hydrogens. The molar mass of phosphorus is 30.974. We're going to round that to 30.97 grams per mole. And the mass of hydrogen will be rounded to 1.01 grams per mole. If we multiply across, phosphorus doesn't change because there's only one atom of phosphorus in that formula. 3 times 1.01 is 3.03. To find the total mass of phosphorus trihydride, we're going to add up the masses of the individual elements. So the total mass of phosphorus trihydride comes out to 34.00 grams per mole. Let's take that value and plug it into our dimensional analysis table. One mole of pH3 equals 34.00. Let's use our calculator to determine the answer. 8.5 times 1 is 8.5, so we're just going to divide 8.5 by 34. Our given value has 2 significant digits, so our recorded answer will also have 2 significant digits. 0.25 moles of pH3 is our final answer. Remember, the grams of pH3 cancel. In problems 5 through 8, we're asked to convert moles of a substance to mass of a substance. We are still using the conversion factor. 1 mole equals the mass of the substance in grams. This time on the mole map, we'll be going from moles to grams. Our given value in the first problem is 1.36 moles of copper 2 phosphate. We're going to solve using dimensional analysis. Let's plug in our units. Since we're canceling out moles of copper 2 phosphate, we will write that at the bottom, and we're solving for grams, so grams will be up at the top. Let's use the periodic table to look up the molar mass of copper 2 phosphate. In copper 2 phosphate, we have 3 atoms of copper, 2 atoms of phosphorus, and 8 atoms of oxygen. The mass of copper is 63.546. We're going to round that to 63.55. The mass of phosphorus is 30.974. We're going to round that to 30.97. And the mass of oxygen is 15.999, and we're going to round that to 16.00. Let's get our calculator out to determine the molar mass of copper 2 phosphate. 3 times 63.55 is 190.65. For phosphorus, 2 times 30.97 is 61.94. For oxygen, 8 times 16 is 128.00. To find the molar mass, we're going to add up the mass of the individual elements. 190.65 plus 61.94 plus 128. That comes out to 380.59 grams per mole. This is the molar mass of copper 2 phosphate. Let's plug that into our dimensional analysis table. 380.59 grams of copper 2 phosphate is the molar mass of that substance. Now we're going to determine the number of grams in 1.336 moles by multiplying the molar mass by that number of moles. Our given value has 3 significant digits, so our final answer will be rounded to 3 significant digits. 518 grams of Cu3PO4 is our answer. Our next example is number 7. We're given 2.00 times 10 to the power of 5 moles of aluminum fluoride. Let's set up our dimensional analysis table. We want to cancel out moles, so moles of aluminum fluoride will be at the bottom. And we're converting this to grams, so grams will be at the top. Let's see how many grams of aluminum fluoride is in 1 mole of aluminum fluoride by looking at the periodic table. In 1 formula unit of aluminum fluoride, we have 1 atom of aluminum and 3 atoms of fluorine. The molar mass of aluminum on the periodic table is 26.982. We're going to round that to the hundredths place, 26.98. And the mass of fluorine on the periodic table is 18.998. We're going to round that to 19.00. Let's multiply across. 3 times 19 is 57. The molar mass of aluminum fluoride is 83.98 grams per mole. Let's take that value and plug it into our dimensional analysis table. And now let's solve. 2.00 exponent 5 times 83.98. That's a really large answer. We're going to record this value in scientific notation and using significant digits. So our given value has 3 significant digits. 2.00 has 3 significant digits. So our final answer will also be recorded in 3 significant digits. 1.68 times 10 to the power of 7 grams of aluminum fluoride is our final answer. And that's how you perform one-step conversions from moles to grams and grams to moles.